I'm going to continue on with similar problems here. Now we are in a class of 26 students. We want to know the probability that we pick Ben, Jill, and Pam in that order to give their class reports next period. Sorry, in any order. It says in any order. So Ben, Jill, and Pam in any order. So the probability of picking one of them, they're 3. I don't care which one I get because it said in any order is going to be 3 out of 26. After I pick one of them, there are only 2 of them that are left. And there's one less person in the class as well. And then I've got to get the last one. The probability of that last one is 1 out of 24. Now this one does say to round to 6 decimal places. And a lot of calculators, when you go to type this one in to get the decimal place, it's going to give you scientific notation. So the scientific notation, we've seen the really large numbers. That's when we get the E that stands for the exponent. So let me just write out what I got. We haven't seen one that has the negative exponent. That means we're going to be really, really small. We're going to be moving our decimal to the left. If you think on a number line, the negative number's on the left side. So we're going to move it 4 places. 1, 2, 3, 4. And we always have to fill in those zeros. So I get 0.000. And I want to go to 6 decimal places, so 385 as my final answer. If you're a patterns person, if this isn't a coincidence, you'll have as many 1 less 0 than what the number's out there. So the number was 4, I would have 3 zeros. If the number was 7, I would have had 6 zeros. That's always the case when we're moving this way. All right, here's another one where we're going to have decimal places because it wants us to round to 8 decimal places. So we've got our chart, so I just have to read off the chart. The probability of being dealt 2 pairs. So I'm going to come along here. Here's 2 pairs. And I don't have to actually know what that is. I just have to read the chart. I don't know how I have to figure out the 2 pairs. Just it was given to me. And the total is also given to me. And then I'm going to type that in my calculator. It said to round to 8 decimal places. So let me carefully copy those 8 decimal places down. Right. A few more examples down here. The probability, if we draw 5 cards, that we're going to get all red. So remember back that there are 26 red cards and there are 52 total cards. And I want 5 of them. And we are going to assume with cards that once you get one, you're going to keep it, unless it says otherwise. If I want you to put the card back in the deck, I will totally tell you that. And we'll get to those differences a little bit later on. But every time I give someone a card, I have less of them in the deck. So that's why we've got this decreasing by 1. So that's 5 cards, always multiplying those together. Some calculators will not reduce these down for you. It didn't say decimal places, so I totally need to keep it as a fraction. If your calculator will not give it to you as the fraction, what you do is just type in the top part. So just type in the numerators only and get that answer. Type in just the denominator and get that answer. If your calculator will reduce it down, that's great. If it won't reduce it down, you can totally leave it just like this. I will take either answer. My math lab will take either answer. This reduced down, I'll just go ahead and tell you, is that. But either answer would be completely fine, or anything in between. This last one on the page, I think is probably the most complicated. Anytime we start dealing with digits, it gets confusing because the digits in the problem don't, people get it confused with the actual probability numbers I'm using as well. So I'm going to be looking at these numbers right up here. Only those numbers. We're going to make a 5-digit number. So 1, 2, 3, 4, 5. And we're going to be multiplying together. We want to find the probability that the number is even. Well, to be an even number, you have to have an even number in the ones place. For instance, 12 is even, but 13 is not, because 2 is even and 3 is not. So the only even numbers I have are 2 and 4. So that means there are 2 choices for the ones place. And honestly, it doesn't matter where you put that because the order for multiplication doesn't matter. You can switch the order. 5 times 3 is the same thing as 3 times 5. So order is not important. I'm just going to put it down there at the end so we remember that that was the ones place. But it doesn't super matter. Once I've chosen that number, and again, that's not the number 2, that's saying I have 2 choices. I can choose 2 or 4. So let's say I picked out 4. Now, there are only 4 numbers to choose from. Let's say I picked out the 5. Then there are 3 numbers, then 2 numbers, and then there's just 1 number. Those are my numerators. The denominator, I started with 5 numbers total, and each time I was choosing 1. So we see that decreasing by 1. Again, the order doesn't matter. I know that 2 over 1 looks a little wonky at the end. If you would rather start with the 2 over the 5, you can totally do that as well. If we type that in, we can reduce this one down to get a final answer of 2/5. I've got another one like this one. Let me give myself a little bit more room by zooming in. I need to get my numbers back up here. So again, I'm looking at these numbers up here. I've got a 5-digit number. And I want the first and last digit to be even. There are only 2 even numbers. So let's say for the first digit, I go to choose. It has to be an even number. There are only 2 choices. This last one also has to be an even number. But I've already chosen 1 even number. Let's say I chose the number 4 again. That means I only have 1 choice for the ones place down there, and the first and the last digits have to be even. So now I've used both my even digits. So now there are only 3 choices for that middle number, then 2 choices, then 1. For my denominators, I started with 5 and I picked a different number each time. Typing that in, I get 1/5.